So now let's look at some functions that are handy for debugging, and I'm going to go ahead and create another file, new PHP file called debugging. And I need something a little complicated that I can play around with to really demonstrate how this testing works. So I'm going to implement something called the callat sequence, or sometimes called the Hailstone sequence. And the rules are pretty simple. So basically it's going to work like this. The callets of n is equal to callets of n over 2 if n is even, and it's equal to callets of n times 3 plus 1 if n is odd, and then repeat that until n is 1. So for example, callets of 2 is even, so callets of 2 over 2 is 1. Callets of 1 we kick out. Callets of 3 is not even, so we multiply 3 times 3 is 9 plus 1 is 10. Then we do callets of 10 is even, so 10 over 2 is 5. 5 times 3 plus 1 is 16. 16 over 2 is 8. 8 over 2 is 4. 4 over 2 is 2. And finally 2 over 2 is 1. So we kick out. It's believed that this will terminate for all numbers greater than 0, but that's never actually been proven. So what I'm going to do is I'm going to create a function that calculates how many steps are required for any input before it kicks out with 1. So let's do function of callets, and it's going to take a number n, and then if n is equal 1, then we'll return 0. So 0 steps for n to be equal to 1. Else, if n mod 2 is equal 0, that means n is even, so we'll return 1 plus callets of n over 2. So for example, if n is 2 is even, so we return 1 plus callets of 1. Then callets of 1 is 0, so callets of 2 will return 2. Else, we know that n is odd, so we'll return 1 plus callets of n times 3 plus 1. Okay, and that's all there is to the callet sequence. Let's go ahead and test it. So I'm going to go for $i equal 1, $i less than 10, $i plus plus, so that's going to be the numbers from 0 through 9, echo $i dot callet's length dot callets sub $i. So let's go ahead and test this out. I'm going to go to debugging.php. I need to add a break here to clean up the output a little bit. So reload it. Great. So we see 7 steps for the number 3, 16 steps for the number 7. So now we have something that we can debug a little bit and see whether it works. So the first function I wanted to show you is debug print backtrace. So let's go ahead and if n is 1, let's see how we got here. So I'm going to call debug print backtrace. And then let's go ahead and comment this out. I only want to test one value. So let's echo callouts of, what was the number? Let's do 7 because that was complicated. Callouts of 7. Great. So what this is going to do is it's going to come in with 7, and then it's going to go 22, and then it's going to go 11, 34, 17, and so on. So it'll loop through all these numbers, and when it finally does get to 1, it's going to show the whole stack. And let's see how we got there. Okay, so that worked, but it's a little hard to read. So what I really want to do is I want to add some pre-format tags here. And that's going to preserve the formatting that's coming out of debug print backtrace. And then hit reload. Great, so that's better. So we start at the top with callout sub 1, and we got called here from callout sub 2 on line 22. So let's put the line numbers in here. So we were here where we called callout sub 1. And we were on the same line where we called from callout sub 4, callout sub 8. Callout sub 16 was called from line 24. So here, so 5 was odd, and so we called 16 from line 24. 10 was even, so we called from line 22, and so on. So 7, 3 times 7 plus 1 is 22, 22 over 2 is 11, 11 times 3 is 33 plus 1 is 34, 34 over 2 is 17, and so on. So you can trace back through all the function calls and see exactly where you were when a particular value was passed, and you can see what that value was. So it'll show you each value that was passed in. Now, most of the other functions that are listed we've seen already. So for example, we've seen echo, we've seen how you can use it to add formatting tags and also to print the value of variables. I just want to point out that it's useful for tracking variables in your program. So for example, I can echo a debug statement that says got even number n and got odd number n. Get rid of the backtrace. Oh, so we need to add some break statements here as well. Forgot my closed quote. There we go. So once again, I can see the values of n, 7, 22, 11, 34, 17. Same thing I saw in the backtrace, but I can control exactly what gets output. So I can also say, for example, passing in n times 2, or here, passing in n times 3 plus 1. This should actually be n over 2. So I can actually see how the values are being passed through the program. For example, 5 is an odd number, so I'm passing in 16. Printar, we've seen, is really useful for printing the values of arrays. So let's go ahead and make an array. Instead of just echoing $i, let's go ahead and create a result array. And then instead of echoing I, I'm going to set result sub $i equal to callat sub $i. So now I have an array of results. And here I'm going to use printar to show that array. So here's the array. And it's showing the key, value, and so on. Works for associative arrays as well. Let's go ahead and get rid of these other debug statements. And hit reload. So that's a little easier to read. You can use Var Dump as well, which will show both the value and type of a variable. So for example, let's go ahead and Var Dump $n here, and we'll also Var Dump $n here. So it's showing me that these are all integer values, which is what I want, and also showing me the value of the integer at each point. getType will return the type of the variable, so echo getType of $n, which should be int. Integer, integer, integer. Let me go ahead and put a break in here. So that's useful if you're not sure whether something is a string or an integer or a floating point number. And finally, get defined vars. So get defined vars is going to show me all of the variables that are defined inside of a particular function scope along with their values. So for example, let's go back to this variable, let's go back to this function refs thing, and I'm going to add a call right here before the return statement, get defined vars, and then I'm going to use printar to show that. So get defined vars is going to return an associative array with all the defined variables and their values. And then let's load function refs. Let me go ahead and comment that up from before. Right? So in order to make that get called, I have to pass in a value so that this else clause gets executed. There. So here's all the defined variables. I have volts, which is 4.2, ohms 0.3, amps 14, watts 58.8, and then I get my output line. So let's go ahead and add a global variable as well. Some global variable equals hello Ohm's law, and reload. So you see it's only showing the variables inside of the current scope. If I go ahead and add another statement, let's go ahead and add an echo break here, and then I'm going to copy this and paste it here. This should show me the value of the global variables as well. So I get my local variables inside the function, and then I get all of the global variables that are currently bound in PHP. And they include success, which is right here, and my watts and my amps are also global. Some global variable, which I set to hello Ohm's law. And then you have a bunch of other global variables, that the superglobals that you get in PHP. So you can see all these values. Between these functions, it makes it pretty easy for you to actually examine what your program is doing and to try to pin down where the results aren't matching what you expect them to. I usually use the debugger for most debugging, so if I want to know the value of success, for example, here I'll just go ahead and put a breakpoint in, and then listen for connection, and hit reload. And I have access to all the same variables that I would get using print statements. So generally speaking, if you're working in a debugger, then your life is going to be a lot easier. You can even open one of these values and see. I saw these values when I printed get defined vars, but it's a little more convenient to just open and close them. But you're not always going to have a development environment that gives you access to the source code. For example, if you're trying to debug a site that's on a remote server, you may not actually be able to open the file in PHP Storm and run it under a debugger. Xdebug has to be installed in the remote server for that to work, and it has to accept callbacks and all that other stuff, the configuration stuff we did in week 1. So if you do find yourself in that situation, you may be forced to rely on print statements, printr, echo, get defined vars, getting the backtrace using debug print backtrace, and so on to do your debugging. And hopefully you'll know how to now.